Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for better preparation of your exams. So, today, students, we will be solving JEE 2024 30th Jan shift first question paper. Okay. In this particular video, I will be solving physics part of the paper. Okay. So here we go. The first question of this series is question number 31. Match list 1 with list 2. Okay. We have to match these with the with the dimensions given in the first, second, third, four options. Okay. So first one is coefficient of viscosity. Okay. The coefficient of viscosity is what? It is also known as the dynamic viscosity or simple viscosity. It is a measure of fluids resistance to flow. Okay. Coefficient of viscosity is a measure of fluids resistance to flow. It is the ratio of the applied stress to the rate. Okay. So we write coefficient of viscosity as force equals to 6 pi eta r into V, where eta is the coefficient of viscosity. So eta is equals to force over 6 pi r into V. 6 pi is constant. So eta will be equals to F over r into V. And we know that the dimension for force is equals to MLT minus 2 over R is L and V is LT minus 1. So it become L cancels out each other. So it will become ML minus 1 T minus 2 plus 1 means coefficient of viscosity is equals to ML minus 1 T minus 1. So the A, it matches with the third option, ML minus 1, T minus 1. Okay. Now the next one is surface tension. Surface tension is what? Surface tension, it is a tendency of a liquid surface to shrink. Tendency of a liquid surface to shrink into smallest possible area. Okay. It is surface tension is also known as interfacial force. So dimension for surface tension is given as surface tension is equals to force over length. So it will be equals to force MLT minus 2 over length is L. Okay. So dimension for surface tension will be LL cancels out each other. So it will be MT minus 2 L 0. So the surface tension matches with the fourth option ML0 T minus 2. Okay. Now the third one is angular momentum. Angular momentum is a physical quantity that is rotational equivalent of a linear momentum. Angular momentum is a physical quantity. It is rotational equivalent of linear momentum. Okay. Linear momentum. It is also a conserved quantity, which means that the total angular momentum of a closed system remains constant. Okay. So angular momentum L is what? MVR. So it will be M for mass, V L T minus 1 and R is L. So it will be equals to M L 2 and T minus 1. So the dimension of angular momentum is ML2 T minus 1. So C matches with option second. Okay. Now rotational kinetic energy. Rotational kinetic energy is what? It is the kinetic energy that results from object's rotation. When an object rotates, object's rotation. When an object rotates, so it gives us rotational kinetic energy. Okay. It is also known as angular kinetic energy. So the dimension for rotational kinetic energy is equals to half m, sorry, half I omega square, since it is a rotational kinetic energy. So it will be equals to m L2 T minus 2. Okay. So it matches with option A. So the correct option is option C. A matches with third, B matches with 4, C matches with second, and D matches with 1. Okay. Now next question. 32. All surfaces shown in the figure are assumed to be frictionless, and the pulleys and the string are light. The acceleration of the block of mass 2 kg is. We have to find the acceleration of this 2 kg mass. Okay. So this question is from the chapter of kinematics. Now, let us draw this figure. This is angle 30 degree. This is mass of 2 kg. Okay, this is a pulley. This is attached with it, and this is 4 kg and frictionless means here is no friction. Okay, and pulleys and string are light. These pulleys and these strings are light. Okay, we have to find the acceleration of the block of mass 2 kg. Okay, let us see now. Let us say in both the string the tension force is T. Okay, if the tension force is T in both the cases, so the total tension here will be in this string will be 2T. Okay, and here also the tension force is T. Okay, now this is 4 kg, so the downward weight will be mg. M means 4 into g. Okay, and here 2 kg. So 2 kg, and this is sine, this is 30 degree. So in this direction it will be mg sine 30. So mg sine 30 means m is what? 2 kg into g into sine 30 is 1 by 2. So it will be having a weight of g. Okay, this is having this downward direction weight is 4g, and weight in this direction is g. Okay, now in tension in this string is T, and tension in both this string is T and T. So the combined tension is 2T. Now using T dot A equals to 0. Okay, using this we get, let us say the acceleration of this block is A1. Okay, let us assume the acceleration of this block is A1, and the acceleration due to this tension in the string is A. Okay, now for this T dot A1 minus, and for this since it is in downward direction, so 2T into A, it will be equals to 0. So solving this, A1 minus 2A equals to 0. So A1 is equals to 2A, means the acceleration of due to this block in this direction is 2A. Now we have to find the value of this A, then we will get the acceleration due to this block of mass 2 kg. Okay, now for this block, since the tension is in this direction, so we write the equation T minus this G is equals to what? Mass into acceleration. Mass is what? 2, and acceleration is A1 means 2 into 2, 4A. Okay, and for this we write 4G minus tension in upper direction is equals to 4A. Mass into acceleration. Mass is what? 4 kg, and acceleration is A. So 4A. Now multiplying this equation with 2, we get 2T minus 2G equals to 8A. And here we get 4G minus T equals to what? 4A. Okay. Sorry, here is 2T, not T. 2T. Now adding both the equation, we get 2T cancels out, is a 4G minus 2G. 2G is equals to 8 and 4, 12A. So we get A is equals to G over 6. Now putting this value of A in this, we get A1 is equals to 2 into G by 6, means A1 is equals to G by 3. So the acceleration. So the acceleration of the block of mass 2 kg is G by 3. So the correct option is B. Now question number 33. A potential divider circuit is shown in figure. The output voltage V0. We have to find this output voltage. This question is from the chapter of current electricity. Okay. Now from this circuit diagram, we see that 1, 2, 3, 4, 5, 6, 7, 8. These 8 registers are in series. So we add them algebraically and we get 700 ohm. 1, 2, 3, 4, 5, 6, 7. 700 ohm plus 3.3 kilo ohm. R equivalent is equals to this. So it will be equals to 700 ohm plus 3300 ohm. So it will be 4000 ohm. Okay, R equivalent of the circuit is 4000 ohm. So since from Ohm's law, V equals to IR. So I will be equals to V over R. V is what? 4 volt. So it will be equals to 4 over R is what? 4000. So it will be equals to 1 over 1000 ampere. Okay. Now we have to find this V naught. So again using Ohm's law, V naught is equals to I into R. So I is what? 1 over 1000 and R is what? Across this, how many resistors are there? 1, 2, 3, 4, 5. Across this voltage V naught. So R is what? 500 ohm. So into 500. So it will be equals to 5 over 10 means 0.5 volt. So our answer is 0.5 volt. Option C. Now next question 34. Young's modulus of a material of a wire of length L and cross-sectional area A is Y. We are given Young's modulus equals to what? Y. Okay. Now, if the length of the wire is doubled and cross-sectional area is half, then Young's modulus will be. So this question is from the chapter of properties of solid and liquid. Properties of solid and liquid. Okay. Now we are having double length and cross-sectional area is half. So student, Young's modulus is a material property. It depends only on the material, not on the length and cross-sectional area. Young's modulus is a material properties does not depends upon the length and upon the cross-sectional area. So the Young's modulus will remain same. So the correct answer is option C, Y. Since Y is equals to stress over strain, it does not depends on the length or on the cross-sectional area since it is a material property. So it will remain the same. So the correct answer is option C. Now question 35. The work function of a substance is 3.0 electron volt. The longest wavelength of light that can cause the emission of photoelectrons from this substance is approximately. So it is asking about the photoelectrons. So this is from the photoelectric effect. Okay. It is from the photoelectric effect. Okay. For what is photoelectric effect? Let us say this is a metal surface and the photons are incident on the metallic surface. After the photons incident, when the photons are incident on the metallic surface, the electrons are ejected from the surface of the metal. Okay. And these ejected electrons are called photoelectrons. Okay. Photoelectrons. When photons of a subsequent frequency falls on the surface of the metal, the electrons are ejected from the surface of the metal and these electrons are called photoelectrons. So here the work function phi is equals to hc over lambda. Since the equation for these photoelectric effect is kinetic energy of these electrons is equals to initial kinetic energy minus the work function phi. Okay. So this work, the question is about this work function. So this work function phi is equals to hc over lambda. we have to find the longest wavelength. Okay, since the value of hc is not given in the question, so we take the value of hc equals to 1243, okay, over lambda. So lambda will be equals to 1243 over 5. 5 is given as 3 electron volt. So lambda, solving this, we get lambda equals to approximately 414 nanometer. Okay. So the correct answer is 414 nanometer. Okay. Since this is in nanometer, 1243 in nanometer. Okay. Now next question 36. The ratio of the magnitude of the kinetic energy to the potential energy of an electron in the fifth excited state of a hydrogen is. So this question is from the chapter of atomic and nuclei. Atomic and nuclei. So according to this question, we have to find the ratio of the kinetic energy to the potential energy. As we all know that the kinetic energy is always the total energy, and it is always equals to 1 by 2, yani half of the potential energy. Okay, it means kinetic energy is equals to half of the potential energy. So it is asking about the ratio of kinetic energy to potential energy. So students, whatever be the excited state, the ratio of kinetic energy or potential energy will always remains the same, that is 1 by 2. Okay, so the correct option is C. The number of excited state does not affect this ratio. It will always be constant. It will always be equals to 1 by 2. Okay. Now next question. Question 37. A particle is placed at the point A of a frictionless track ABC as shown in figure. It is gently pushed toward right. The speed of the particle when it reaches the point B. Okay, we have to find the speed of the particle when it reaches the point B. So this question is from the chapter of work, energy and power. Okay, so let us say when the particle starts from point A, it is having initial velocity u equals to 0. Okay. Now, when it reaches to point B, let us say its velocity is Vb. Okay. So we have to find this Vb. We have to find this Vb, velocity of the particle at point B. Since this is 1 meter, this is 0.5, means this is also zero point 0.5 meter. Okay. And we all know that the loss in kinetic energy, the loss in kinetic energy is equals to gain in potential energy. Gain in potential energy. So when the ball moves, when the particle moves from point A to point B, it loses its kinetic energy and there will be a gain in potential energy. So half mv square loss in kinetic energy, it will be equals to gain in potential energy mgh. Okay, so cancels out. So v square equals to 2gh. So v will be equals to under root of 2gh, means under root of 2 into g. G is 10 and height is 0.5. So it will be equals to under root of 10 meter per second. Okay. So velocity is under root 10 meter per second. So the correct option is B. Now question 38. The electric field of an electromagnetic wave in free space is represented as E equals to E naught cos omega t minus kz iota cap. The corresponding magnetic induction vector will be. So this question is from the chapter of electromagnetic wave. Electromagnetic wave chapter. So E is given as E naught cos omega t minus kz iota cap. Okay, it means x, y, z. It means the electric vector is in this direction. Okay, so and its equation is given as E equals to E naught cos omega t, where E naught is the amplitude, omega is the angular frequency, k is the wave vector. Okay, and iota cap is telling that the electric field is in, electric vector is in x direction. Okay, now we have to find the magnitude of the magnetic induction vector B. Okay, as we all know that E equals to BC. E equals to BC. This is the very important formula. E equals to BC. So the magnetic induction B will be equals to E by C. It means E naught cos omega t minus kz into iota cap over C. C is what? Speed of light. Okay. So since C is E cross B, okay. C is what? E cross B. Okay. If the electric vector is in direction, okay. Student, if the electric vector is in iota direction means is in x direction, so the magnetic field will be in the y direction, okay. So it will be J cap. If the electric field is in this x direction, so the magnetic field will be in the y direction. So this space xy is called field of oscillation. Okay, field of always remember, when the electric field is in x direction and magnetic field is in y direction, so the xy plane is called field of oscillation, and the field perpendicular to this means this xz plane, this plane is called field of polarization. Okay, so it is just asking us about the magnetic field. So we use just the famous formula E equals to BC. So B equals to E by C, E naught cos omega t minus kz in and J direction. Okay, so our correct answer is option B. Okay, now next question 39. Two insulated circular loops A and B of radius A carrying a current I in the anti-clockwise direction. The magnitude of the magnetic induction at the center will be. So this question is from the chapter of magnetic effects of current and magnetism. Okay, current and magnetism. So it is saying that there are two loops. Okay, there are two loops. Let us say this is A and B. The current is flowing in anti-clockwise direction. Okay, so using the right hand thumb rule, from according to right hand thumb rule, the if the current is flowing in anti-clockwise direction in this loop B, so the magnetic field will be in this direction. Okay, and in loop A, if the current is flowing in this direction, so the magnetic field direction will be in this direction B and B. So their resultant will be at the center. So the resultant magnetic field, magnetic induction at the center will be this. Okay, so for this we write the resultant magnetic field B will, this is root 2 and radius is A, so this is root 2 है ना. So root, so B resultant will be equals to root 2 into magnetic field due to 1 mu naught I over 2A, since the radius is A. So we write B resultant will be equals to this root 2 into mu naught I over 2A. So the correct option is option C, root 2A. Okay. Now next question. Question 40. The diffraction pattern of a light of wavelength 400 nanometer diffracting from a slit of width 0.2 millimeter is focused on focal plane of a convex lens of focal length 100 centimeter. The width of first secondary maxima. Okay. So this question is from the wave optics. Wave optics. Okay. According to this question, let us say this is a slit and a light, coherent light source is what? Coherent source. Okay, coherent light is coming from the source and it is passing through a slit. After passing through a slit, it is making wave fronts, and these wave fronts are incident on a screen. This is slit and this is a screen, and the wavefronts are making a central maxima at the center. This is central maxima, and from let us say this here is second slit. So the coherent light coming from this second slit, different wavefronts are forming from it, and when these wavefronts they interface, they are making a central maxima. Along with the central maxima, they are making different alternate dark and bright fringes also. Okay, so the question is asking about the width of the first secondary maximum. Means this is the central maxima, there will be first secondary maxima, here will be first secondary maxima, so we have to find the width of first secondary maxima. So width of first secondary maxima will be equals to lambda over a into d, where d is the distance between screen and the slit. Okay, now here in this question, A is what? 0.2 into 10 to the power minus 3 meter. Okay. And lambda is what? 400 nanometer. Lambda is 400 nanometer, means 400 into 10 to the power minus 9 meter. And D is given as 100 centimeter. Okay. D is 100, means 100 into 10 to the power minus 2. So width will be equals to 400 into 10 to the power minus 9 into 100 into 10 to the power minus 2 over 0.2 into 10 to the power minus 3. So it will be equals to 2 millimeter. So the width of the first secondary maxima is 2 millimeter. 2 millimeter. Okay. So our next question is question 41. Primary coil of a transformer is connected to 220 volt AC. Primary and secondary turns of the transformers are 110 respectively. Secondary coil of a transformer is connected to two series resistance shown in figure. The output voltage V0. We have to find this output voltage V0. So this question is from the chapter of electromagnetic induction and alternating currents and alternating current. Okay, so it is asking about the transformer. So first of all, what is a transformer? A transformer is a passive component that transforms what? Electrical energy from one circuit to another. Okay, it is a passive component that converts electrical energy from one circuit to another circuit. In this given diagram, this is primary coil and this is secondary coil. Okay, so transformer converts the electrical energy from one circuit to another circuit. Okay, and it operates on the principle of electromagnetic induction. So whenever in MCQs the question is asked about on which principle the transformer works, so it always works on the principle of electromagnetic induction, means the current that is produced in primary coil generates an EMF in the secondary coil. An EMF is generated in the secondary coil due to the current of the primary coil. Okay, now there is a direct formula between the EMF and the number of coils. These are the number of coils. So there is a direct formula between the EMF generated in the primary coil due to the current generated EMF generated in secondary coil due to the current of the primary coil, that is EP equals to an EP over ES, means EMF of primary coil equals to number of turns in the primary coil and EMF of secondary coil equals to number of turns in the secondary coil. Okay, so it will be equals to number of turn in secondary coil are what? We can write it as E1 over E2 equals to N1 over N2. Okay, for the convenience, N1 is what? 100 and N2 is 10. So E1 E1 over E2 will be, and E1 is what? Primary coil 220 volt. Okay, so 220 volt over E2 equals to 100 over 10. So E2 will be equals to 0 0 cancels, E2 will be 22 volt, okay? And it is asking about the what? Output voltage V naught. So output voltage V naught is, since from the Ohm's law, V equals to IR, okay? So I, first of all, we have to find the I. I is equals to V over R, and V is what? 22. So 22 over R. R is given as what? This 15 kilo ohm and 7 kilo ohm, these resistance are in series. So total resistance will be 15 plus 7 is what? 22 kilo ohm. Okay. So R is what? 22 kilo ohm means 22 into 10 to the power 3. So I will be 10 to the power minus 3 ampere means I equals to 1 milliampere. So voltage V naught will be equals to this 1 milliampere into R. R is what? 7 kilo ohm. We have to find the output voltage V naught na. So the resistance across this voltage V naught is 7 kilo ohm. So 1 into 7. V naught will be equals to 7 volt. Okay. So the correct option is option A. Now next question 42. The gravitational potential of a point above the surface of Earth is minus 5.12 into 10 to the power 7 joule per kg, and the acceleration due to the gravity at the point is 6.4 meter per second square. Assume that the mean radius of the Earth to be 6400 kilometer, the height of this point above the Earth's surface. So this question is from the chapter of gravitation. So according to this question, let us say this is Earth, and let us say this is a point P. So the gravitational potential at this point P is what? Gp minus 5.12 into 10 to the power 7 joule per kg, and acceleration due to gravity is, a acceleration is given 6.4 meter per second square. Okay, we have to find the height of this, we have to find this h. So according to question, Gp is this much, and acceleration due to gravity means G naught. Acceleration due to gravity means Z naught is 66.4 meter per second square. If we divide both these equation, we get Gp over G naught. First of all, Gp is what? Minus Gm over R plus this H. Okay. Means the gravitational potential at this point P is defined by minus Gm over R plus H. This H, okay? R is what? Radius of the Earth, and it is given as this minus 5.12 into 10 to the power 7. And G naught is given, the formula for G naught is Gm over R plus H whole square, okay? And it is given as 6.4 meter per second square. So dividing these two equations, we get R plus H cancels, Gm cancels. So we get so we get Gp over G naught is equals to minus of this, minus becomes plus. So plus 5.12 into 10 to the power 7 over 1 over means into R plus H into 6.4. Okay, let us say Gp will become, wait a minute, Gp will become minus cancels out each other. So it will become direct 5.12 into 10 to the power 7. And this G naught will become what? 6.4 into R plus H, na? So we will get 6.4 into R plus H. So solving it and putting R equals to 6400 kilometer, we get H height is equals to what? 16 into 10 to the power 5 meter, that is 1600 kilometer. Okay, just putting the value of R here and we find the value of H. Okay, now next question 43. According to this question, an electric toaster has a resistance of 64 ohm and at a temperature of 27 degrees Celsius. The toaster is connected to a 220 volt supply. If the current flowing through it reaches 2.75 ampere, the temperature attained by the toaster is. Okay, so this question is from the chapter of thermodynamics. Thermodynamics. So a toaster is a heating element. An electric toaster is a heating element which converts electrical energy into thermal energy. Okay, electrical energy into thermal energy. It is a heating element that converts electrical energy into thermal energy, and the heating element used in the electric toaster is what? Nichrome. Heating element is nichrome. Okay. In this electric toaster, the electricity flows through the filaments, which gives out heat due to the high resistance. Okay, so the electric toaster has a very high resistance. Okay, now according to this question, we are given with when the temperature is 27 degrees Celsius. When the temperature is 27 degrees Celsius, at that time the resistance is at 27 degrees Celsius, the resistance is 60 ohm. Okay. And the voltage is given as 220 volt. Okay. Now we have to find the temperature at which the current is 2.75 ampere. Okay. Now, resistance at T equals to 27 degrees Celsius is given as 60 ohm. So, resistance at temperature, the temperature which we have to find, at first we will find its resistance from the Ohm's law. V equals to IR. So R will be V over I. V is given what? 220 volt and I is 2.75 ampere. So 220 over 2.75. It will be equals to 80 ohm. Okay. Now the equation for electric toaster is given as electric toaster. The equation is R equals to R naught 1 plus alpha delta T. So R is what? At which we have to find the temperature. It is 80 and R naught is 60. 1 plus alpha. Alpha is given as 2 into 10 to the power minus 4. 2 into 10 to the power minus 4 into delta T. We have to find this delta T. Okay. Now solving it, we get 80 equals to 60 plus 60 into 2, 120 into 10 to the power 5 minus 4 into delta T. So 80 minus 60 equals to 20. It will be equals to 120 into 10 to the power minus 4 into delta T. So 2 cancels out, 0 cancels, 2 in 6, 12. So delta T will be equals to 1 over 6 into 10 to the power minus 4, means delta T will be equals to 1 over 6 into 10 to the power plus 4, and converting it into degree Celsius. Okay, so we get temperature is equals to 1694 degrees Celsius. Since this temperature will come in terms of Kelvin, something, let is this temperature plus 273 comes out to be in Kelvin. So converting this Kelvin into Celsius means my temperature minus 273, we will get it in terms of degrees Celsius. So temperature comes out to be 1694 degrees Celsius. So the correct answer is option C. Okay. Now next question 44. A Zener diode of breakdown voltage 10 volt is used as a voltage regulator as shown in the figure. The current through the Zener diode is, we have to find the current through it. Okay. This question is from the chapter of electronic devices. Electronic devices. Now from the figure, this is I1 current, this is I2 current, and this is I3 current. Okay. Now I3 current will be from Ohm's law, V equals to IR. So I equals to V over R. So I3 current will be V over R. V is what? 10 volt. 10 over R is what? I3, 500 ohm. So it will be equals to 1 over 50. Okay. And I1. I1 is equals to voltage is given 10 volt and resistor is of 200 ohm. So 10 over 200 equals to 1 over 20. Okay. Now this I2, we have to find this I2 current now. Since this I1 will be equals to I2 plus I3. So I2 will be equals to I1 minus I3. I1 is what? 1 over 20 minus I3 is 1 over 50. So solving this we get 3 over 100 means 30 milliampere. It is equals to 30 milliampere. So the correct answer is option C. Okay. Since the supply voltage is 20 volt, na, so we divide this 20 volt across the two resistors. This is 10 volt and this is also 10 volt. Okay. Now, next question 45. Two thermodynamical processes are shown in the figure. The molar heat capacity for process A and B are CA and CB. The molar heat capacity as constant pressure and constant volume are represented by CP and CV respectively. Okay, so we have to choose from these 5 statements. Okay, so this question is from the chapter of thermodynamics. Now, according to it, this question is from thermodynamics. Okay. Now, according to it, we are given with a graph having x-axis log p, sorry, y-axis log p and x-axis is log v. Okay. The slope for A process is of tan inverse gamma and for B is 45 degree. Now, we know that since we know a famous relation that Cp is equals to Cp equals to Cv plus R, or we can say that Cp minus Cv equals to R, and also Cp equals to Cv plus R over 1 plus gamma. This gamma is what? Which we will find from the relation PV gamma equals to constant. Okay. This is a famous relation. Now, for process A, for process A, from the graph, we see that log of P is equals to slope is given for process A is tan inverse gamma. Means we'll write gamma into log what? V. Okay, since the slope is tan inverse gamma means theta equals to tan inverse gamma. Means tan theta is gamma. So slope is what? Tan theta and it is given as gamma. So we write log P equals to gamma into log V. Okay. Since we know that Y equals to mx plus C na. So m is the slope. So here the slope is gamma. So we write log P equals to gamma into log V. Okay. So from this we can write P V minus of gamma equals to constant. According to this graphical representation, we can write PV minus gamma equals to constant. It means that we can write for process A, CA equals to CV plus R1 plus gamma. Okay, since here it is gamma only na, so we can write R1 plus gamma. This is for process A. Okay. Now for process B. For process B. Here the slope is of 45 degree. 45 degree means tan 45 is what? 1 means in place of gamma, now we will write only 1. So for process B, we can write log of P equals to 1 into log of V. So for process B, we can write PV minus of 1 equals to constant. Okay. Since in process A the slope is gamma, so we are writing PV minus of gamma equals to constant. And here the slope is of 1, so we are writing PV minus 1 equals to constant. So for process B, we can write CB equals to CV plus R over 1 plus gamma, and here gamma is 1. So 1 plus 1 is what? 2. So CB equals to CV plus R over 2. Okay, this is for process B. And again, there is another equation, that is CP minus CV equals to R. And we can write it as CP equals to CV plus R. This, let us say this is equation C. So from A, B, C, we see that CP is greater from A, B, and C. We see that CP is greater than CB. This is R by 2, na? So it will be 0.5 R, and it is greater than CA. CA means gamma can take any value. We don't know the value of R. So gamma can take any value. So CB is greater than CA. Okay. So the options, none of the above options matches with these results. So the correct answer is option E. Okay. None of the above result. Okay. Now question 46. The electrostatic potential of an electric dipole at a distance r varies as. So this question is from the chapter of electrostatics. Electrostatics. It is asking about the electrostatic potential due to an electric dipole. Let us say that this is a uniform electric field and there is an electric dipole. We have to find the electrostatic potential due to this electric dipole. Let us say this is plus charge Q and this is minus charge Q, and we know that dipole moment P is equals to 2QL, means charge into distance between the dipole, which is 2L. So we have to find the electric potential due to this. And what is electric potential? It is the amount of work that is needed to move a unit charge from a reference point to a specific point in a electric field. Okay. So we know the direct formula for the electrostatic potential due to a dipole is V is equals to Kp cos theta over r square, where the value of k is what? 9 into 10 to the power 9. It is also written as 1 over 4 pi epsilon naught. Okay. So, and so the potential V is directly proportional to 1 over r square, and P is the dipole moment P. So V is directly proportional to 1 over r square. So the correct option is B. Now, next question 47. A spherical body of mass 100 gram is dropped from a height of 10 meter from the ground. After hitting the ground, the body rebounds to a height of 5 meter. The impulse of force imparted by the ground. Okay, we have to find the impulse, since the impulse is nothing but the change in the momentum. This question is from the chapter of kinematics. The impulse is basically what? Change in momentum. Change in momentum. Now, according to question, let us say this is ground. There is a spherical body. Its mass is given as 100 gram. It is dropped from a height of 10 meter, okay, from the ground. It after hitting the ground, the body rebounds to a height of 5 meter. Let us say when it is hitting the ground, its momentum is v1, and when it rebounds to a height of 5 meter, let us say its velocity is v2. So it is impulse is what change in momentum delta p means final momentum minus initial momentum means, let us say final momentum is m2 v2 and initial momentum is m1 v1. Okay, now just uh, put these values and we will get our desired answer. Since mass of the body is same, so just write v2 minus v1, and momentum is what, mgh na. Since half mv square is what, mgh, so v cancels out each other, so v is equals to under root of 2gh. So since the mass is same, just we will get v2 minus v1. Mass, take mass common, so write v2 minus v1, and v is what, under root of 2gh na, so it will be equals to mass is what, 100 gram. 100 gram means 0.1 kg. And V2 is what? 2gh. 2gh means 2 into gravity 9.8 into h is what? 5 meter when it rebounds back. And minus V1. V1 is what? Minus of v1. Since why we are writing minus of v1, since the v1 is in downward direction. Now if we are taking positive in above the ground in this direction, so this velocity v1 we will take it as minus, so this minus eventually becomes positive. So under root of 2g, and height is what, 10 meter, so this minus becomes positive. So we will write this change in momentum means impulse is equals to 0.1 in under root of 2 into 9.8 into 5 minus plus under root of 2 into 9.8 into 10. So it will become 0.1 under root of 14 plus, sorry, not under root, only 14 plus 7 root 2. Okay, so the answer will be 2.39 kg meter per second. So our correct option is 2.39 kg meter per second, option D. Now, next question 48. A particle of mass m projected with a velocity u making an angle of 30° with the horizontal. The magnitude of angular momentum of the projectile about the point of projection when the particle is at its maximum height h is. So this question is from the chapter of kinematics. It is asking about the projectile motion, okay? It is asking about projectile motion. So let us draw this question as, let us say a particle is making a projectile motion. So according to question, the initial velocity is u and the mass of the particle is m. It is making an angle 30° with the horizontal. The magnitude of the angular momentum of the projectile about the point of when the particle is at its maximum height. Let us say we have to find the angular momentum when the particle is at this height, maximum height. So maximum height means h maximum. Okay, and this component will be, this is 30°, so u cos 30°. Okay, this will be sine na, so this will be u cos 30°. So angular momentum L is equals to mvd. So it will be equals to m into v is what? U cos 30. So U cos 30 means root 3 by 2 into D. D is maximum height. Its formula is U square sine square 30 degree over 2G. Now it will be equals to M into U into root 3 by 2 into U square over 2G, and sine square 30 means 1 by 4. Okay. So solving it, we get U cube 2 2 4 4 4 16. So we get it under root 3 over 16 m into u cube over g. So the angular momentum at the maximum height will be root 3 mu cube over 16 into g. So the correct answer is option A, root 3 mu cube over 16 g. Now next question 49. At which temperature of the RMS velocity of a hydrogen molecule equals to that of the oxygen molecules at 47 degrees Celsius? Now, this question is from the chapter of kinetic theory of gases. According to this question, we have to find the RMS velocity. So the direct formula for the RMS velocity is what? Vrms is equals to under root 3 RT over M. If the question is about the average velocity, so at that time we write under root of 8 RT over pi M. If the question is about V most probable velocity, so we write under root 2 RT over M, but it is asking about RMS velocity. So the formula for RMS velocity is under root 3 RT over M. Now we are given with hydrogen molecule and oxygen molecule. So the mass of the hydrogen molecule will be 1 into 2, that is 2, and oxygen will be 16 into 2, that will be 32, and temperature given as 47 degrees Celsius means 47 plus 273. So it will be 7 8 4 12 carry 1 320 Kelvin. Now using the formula under root 3 RT over 2 for hydrogen, it will be equals to under root 3 R into 320 for oxygen over 32. This 32 cancels out. So this 3R cancels out. So we are left with under root T by 2. It will be equals to under root 1. Okay. No, sorry, under root 10, not 1. So squaring both sides, we get T by 2 equals to 10. So we get T equals to 20 Kelvin. So our correct answer is 20 Kelvin, means option D. Okay. Now next question 50. A series LR circuit connected with an AC source E equals to 25 sine 1000 T volt has a power factor of 1 by root 2. If the sound of EMS is changed to E equals to 20 sine 2000 T volt, the new power factor of the circuit will be. So this question is from the electromagnetic induction and alternating current chapter. Electromagnetic induction and alternating current chapter. Okay. Now, according to this question, we have to find the power factor. So first of all, what is power factor? The power factor, we represent the power factor by cos theta or cos phi. The power factor is R over impedance Z, and it is equals to R over Z is what? R square plus XL square. Okay. And the power factor is given as when EMF is 25 sine 1000 T volt, at that time the power factor is given as 1 by root 2. Okay. Now squaring both side, we get R square over r square plus xl square equals to 1 by 2. Now cross multiplying it, we get 2r square equals to r square plus xl square. So r square will be equals to xl square. It means r is equals to xl. According to question, when the power factor is 1 by root 2, at that time r is equals to xl. Now it is asking about the power factor when EMF becomes this. Now, since we know that the standard equation from EMF is E naught sine omega t. Now see carefully, when the power factor is 1 by root 2, at that time the omega is 1000 t. Omega is 1000 t, 1000 when the power factor is 1 by root 2. Now we have to find the power factor when the omega becomes 2000. Means the omega is now 2000, means it is twice the initial value. It becomes double now. So the power factor, new power factor will be r over under root of r square plus xl square. If the power factor is becoming twice and we know that xl is equals to omega l, means xl is directly proportional to omega. If omega is doubled, so xl is also doubled. So new power factor will be r over under root of r square plus 2xl square. Okay, if the omega is becoming twice, so xl will also become twice. So new power factor will be r over under root of r square plus 4xl square. R over under root of r square plus 4xl square. And from this we know that r is equals to xl. So the power factor will become r over under root of r square plus 4r square. So it will be equals to r over under root of 5r square, means 1 over root 5. So our new power factor will be equals to 1 over root 5. So the correct answer is option C. So students, the next question is 51. The horizontal component of Earth's magnetic field at a place is 3.5 into 10 to the power minus 5 Tesla. A very long straight conductor carrying current of root 2 ampere in the direction southeast to northwest is placed. The force per unit length. Okay, we have to find the first force per unit length experienced by the conductor. So this question is from the chapter of magnetic effects of current and magnetism. Magnetic effects of current and magnetism. Since in the question it is said that the straight conductor is placed in the direction from the southeast to northwest. Southeast to northwest means the theta is what? 45 degree. East, west, north, south means the angle between current and the magnetic field. Current and magnetic field. Let us say if the current is in this direction and magnetic field in this direction, so northwest means the angle between current and magnetic field is 45 degree, and southeast means if the current and current is in this direction and magnetic field in this direction, so the angle between them is 45 degree. Okay, so southeast to northwest means the current between so angle between current and magnetic field is 45 degree, and we know that the force is equals to I B L sine theta. Since theta is 45 degrees, so it will be equals to IBL sine 45 degree. Okay. So it is asking force per unit length. Force per unit length means force over length is equals to IB sine 45 degree. And I is given what? root 2A. Current is root 2 ampere and the magnetic field is 3.5 into 10 to the power minus 5 Tesla. So it will be equals to root 2 into B, 3.5 into 10 to the power minus 5 into sine 45 means 1 by root 2. So force per unit length will be equals to 35 into 10 to the power minus 6 Newton per meter. Okay. Now next question 52. Two cells are connected in opposition as shown. Cell E1 is of 8 volt EMF and 2 ohm internal resistance. The cell E2 is of 2 volt EMF and 4 ohm internal resistance. The terminal potential difference of E2. We have to find the terminal potential difference. So this question is from the chapter of current electricity. Current electricity. Okay. According to this question, the 8 volt EMF is connected to 2 ohm internal resistance. Means let us say this is 8 volt and it is connected to 2 volt internal resistance. Okay. And this is point B. This is point A. And cell E2 is of 2 volt EMF and 4 ohm internal resistance. Okay. 2 volt EMF and 4 volt internal resistance. This is point C. 2 volt and 4 ohm. Okay. And we have to find what the terminal potential difference of the cell E2. Let us say this is cell E2, this is cell E1, and we have to find the terminal potential difference of E2. Terminal potential difference means let us say this is point A and this is point B. Terminal potential difference mean we have to find the potential difference between these 2 points. Okay, this is called the terminal potential difference. Okay, now since this is point A, this is C, and this is point B. So net EMF will be equals to 8 minus 2 volt. Okay, this is 6 volt, and R equivalent, resistance equivalent will be equals to 6 ohm. Since these two resistance are in series, so R equivalent will be 6 ohm. Now using Ohm's law, V equals to IR. So I will be equals to V over R means 6 over 6. That is 1 ampere. Means that 1 ampere is 1 ampere current is flowing through this circuit. Okay. Now we have to find the potential difference. So potential difference delta V across E2 will be equals to E2 plus I into R2. So E2 is what? 2 volt plus I is 1 ampere current and R is 4. So it will be equals to 2 plus 4 means 6 volt. So the potential difference across this E2 will be 6 volt. Okay. 6 volt. Now next question, question 53. According to this question, an electron of hydrogen atom on an excited state is having energy minus 0.85 electron volt. The maximum number of allowed transition to lower energy level is. Okay. So this question is from the chapter of atomic and nuclei physics. According to this, we have to find the number of allowed transitions. Okay. Since we know that the energy state, the lowest energy states at it, the energy is minus 13.6 electron volt. Okay. Then this is E1, this is E2. E2 is of minus 3.4 electron volt. Okay. Then E3. E3 is of minus 1.51 electron volt, and E4 is of minus 0.85 electron volt. So according to question, N is equals to 4 means fourth energy state. Okay. Now the number of allowed transition, number of transitions is equals to number of transitions. It is equals to n minus 1 upon 2. So n is what? 4. 4 minus 1 upon 2. So it will be equals to 4 into 3 over 2. 2 2s are 4 means 6. So the number of allowed transitions to lower energy level will be 6. Okay. Now next question, question 54. Each of three blocks P, Q, and R shown in the figure has a mass of 3 kg. Okay. Each of the wire A, B has cross-sectional area 0.005 centimeter square and Young's modulus 2 into 10 to the power 11 Newton per meter square. Neglecting friction, the longitudinal strain on the wire B. We have to find the longitudinal strain. So this question is from the chapter of properties of solids and liquids. Properties of solids and liquids. Okay. Now, it is asking about the longitudinal strain. So, longitudinal strain is what? Since tension over area is equals to Young's modulus into strain, okay? So, strain will be equals to tension over area into Young's modulus. We have to find the longitudinal strain, na? So, we have to use this formula. Strain is equals to tension over this area into Young's modulus. Okay. Since according to question, there are three blocks. Block P, block Q, and block R. Okay. There are three blocks. This is a pulley and this is a string. Okay. Each blocks is having a mass of 3 kg, 3 kg, 3 kg, 3 kg. Okay. So each of the wire A and B has cross-sectional area 0.005 centimeter square. Let us say this wire has a cross-sectional area of 0.005 centimeter square and this wire is also having the same cross-sectional area and the Young's modulus is given by 2 into 10 to the power 11 Newton per meter square. Okay. Now if in this string the tension is T and this string the tension is also T. Okay. And since the mass is 33 kg, so the force acting on it will be 30 Newton. Now using the equation, the 30 Newton minus tension force is what? Mass into acceleration. So mass is 3. Let us say acceleration in this is A. Okay, it will be 3A. And other for this T minus 3 plus 3, 6. So T is equals to 6A. Now, from these two equations, adding these two equations, T cancels. So 30 will be equals to 9A. So A will be equals to 30 over 9. Now putting this value of A in this equation, we get T is equals to 6 into 30 over 9. Okay. So this will be 3 2 is 6, 3 3 is 9, 3 10s are 30. So T will be 20. Okay. Now we have to find the strain. So strain will be equals to tension is what? 20 over area. Area is what? 0.005 centimeter square, na? So it means 0.005 into centimeter square means 10 to the power minus 4 meter square. And Young's modulus is what? 2 into 10 to the power 2 into 10 to the power 11 per meter square. Okay, solving it we get this 2 cancels out each other. So it will be 10 to the power 1 plus 4 minus 11 over this 10 to the power 3. So it will be plus 3 over 5. So this will become 10 to the power 3, 4, 3, 7, 1, 8. 8 minus 11 over 5. So it will be 10 to the power minus 3 over 5 means 0.2 into 10 to the power minus 3. So this strain will be 0.2 into 10 to the power minus 3. Okay, it means 20 into 10 to the power minus 4. Okay. 20 into 10 to the power minus 4. Now next question, question number 55. The distance between object and its 2 times magnified real image as produced by a convex lens is 45 centimeter. The focal length of the lens used is. So this question is from the chapter of optics. According to this question, there is a convex lens. Okay. And 2 times magnified real image means if the object is here, so the image is forming here. And 2 times magnified real image means if the height of the object is h naught, so the height of the image will be 2h naught. Means if the distance of this object is x, so the distance of the image will be 2x. Okay. And the distance between the object and its 2 times magnified real image is 45 centimeter. Means the distance between this to this is 45 centimeter. Means x plus 2x is 45 centimeter. So 3x is equals to 45. So x is equals to 15 centimeter. Okay. Now using the formula 1 over v minus 1 over u is equals to 1 over f. So 1 over v means 1 over 2x. So it means this is 15 and this is 30. Okay. So 1 over v means 1 over 30 minus 1 over u. According to sign convention, this is minus 15 equals to 1 over f. Sign convention means the distance on the left side of the lens will be taken as negative. So we take u as negative. So 1 over 30 minus minus plus 1 over 15 is equals to 1 over f. Now solving this, we get f equals to plus of 10 centimeters. So the focal length of this will be 10 centimeter. Okay. Now next question 56. The displacement and the increase in the velocity of a moving particle in the time interval of t to t plus 1 second are 125 meter and 15 meter per second respectively. The distance traveled by the particle in t plus 2 second is. So this question is from the chapter of kinematics. According to this, we have to find the distance traveled. Okay. Considering acceleration to be constant. Considering acceleration to be constant, since from the laws of motion we know that v is equals to u plus at. Okay, so u plus at means 50. Okay, u plus 50 is equals to u plus a. We have considered this acceleration constant now. So u plus 50 will be equals to u plus a, means a will be equals to 50 meter per second square. Okay. Now s is equals to ut plus half at square. Okay. So s is the displacement and displacement is given what? 125 meter. So 125 will be equals to u plus a by 2. Okay. Now next it will be equals to u will be equals to 100 meter per second using a as 50 meter per second square. So therefore SNth will be equals to u plus a by 2, 2n minus 1. Now putting the values we get it is equals to 175 meter. U is 100 meter per second. A is 50 meter per second square. And N is t plus 2. Okay. So we get SNth will be 175 meter. Now next question 57. A capacitor of capacitance C and potential V has energy E. It is connected to another capacitor of capacitance 2C and potential 2V. Then the loss of energy is, we have to find the loss of energy. So this question is from the chapter of electrostatics. Electrostatics. According to this question, there is a capacitor. Its capacitance is C and voltage is V. Okay. And its energy is E. E equals to half CV square. It is connected to another capacitor of capacitance 2C. Now the capacitance is 2C and potential is 2V. We have to find the loss in energy. Okay. So there is a direct formula for the energy loss. In case of capacitor, it is equals to 1 by 2 C1 into C2 over C1 plus C2 into V1 minus V2 whole square. Okay. Now solving it, we get 1 by 2. C1 is what? C, and C2 is 2C over C1. C plus 2C means 3C. V1 minus V2 means 2V minus V whole square. So it will be equals to 2 cancels out each other. It will be equals to C square over 3C. 2V minus V square. Okay. So it will be equals to C cancels out each other. So it will be equals to 1 by 3 CV square. Okay. And from this relation, CV square is equals to 2 into E. Okay. From this relation. So in place of CV square, we write 2E over 3. So comparing it with the given equation in the question, XE by 3. XE by 3, we get X equals to 2. Okay. Now next, 58. Consider a disk of mass 5 kg, radius 2 meter, rotating with angular velocity of 10 radian per second about an axis perpendicular to the plane of rotation. An identical disk is kept gently over the rotating disk along the same axis. The energy dissipated so that both the disks continue to rotate together without slipping. Okay. So this question is from the chapter of rotational motion. Now, according to this question, at first there is a disk whose mass is 5 kg, radius is 2 meter, and its angular velocity is 10 radian per second. Okay. Now, so its L, angular momentum, will be equals to I into omega, initial angular velocity. So it I is what? For disk, the I is equals to moment of inertia is mr square by 2. So I is mr square by 2 into omega, and omega is given 10 radian per second. So it will be equals to mr square. Mass is 5 kg, radius is 2 meter, means 2 square over 2 into omega is 10. Solving it, we get 100 kg meter square per second. Okay. Now, so initial energy will be equals to half I omega square. So it will be equals to half mr square by 2 into omega square. Putting these values, half mass is 5, r is 2 square over 2, omega is 100 square. So we get energy equals to 2 cancels, 2 cancel. So it will be equals to 500 joule. Okay. Now, since Li, using conservation of angular momentum, conservation of angular momentum, Li will be equals to Lf, means initial momentum will be equals to final momentum. So it will be equals to what? Now, according to question, an identical disk is kept gently over the rotating disk. It has kept another disk over it. So now the total inertia will be I plus I, means 2I on the same axis. Now the total inertia will be 2I. Now for this, it will be equals to 2I omega. So it will be equals to what? 100 initial angular momentum, na? 100. So it will be equals to 2I omega f will be equals to 100. So omega f will be equals to 100 over 2 into I. So solving it, we get 5 radian per second. Okay, putting the value of I is mr square by 2. We get omega f equals to 5 radian per second. Now, final energy will be equals to 2 into half into I means mr square by 2 into omega square means 5 square. So it will be equals to, solving it, we get 250 joule. So what we have to find? We have to find the energy dissipated. So energy dissipated will be equals to delta E initial minus final. Initial is what? 500 minus final 250. So it will be equals to 250 joule. Okay. Now next question 59. According to this, in a closed organ pipe, the frequency of fundamental note is 30 Hz. A certain amount of water is now poured in the organ pipe so that the fundamental frequency is increased to 110 Hz. The organ pipe has a cross-sectional area of 2 cm square. The amount of water poured in the organ tube is. So this question is from oscillations and waves. Oscillations and waves. Okay. Now, according to this question, there is a closed organ pipe. Closed organ pipe means like this. This is closed organ pipe and this is open organ pipe. Okay. Now, according to this question, the closed organ pipe has a fundamental frequency of 30 Hertz. Okay. So, its formula is V over 4L. So, at first we write L1 equals to 30 Hertz and V is given 330 meter per second. So 330 over 4 L1 equals to 30 Hertz. So L1 will be equals to 11 by 4 meter. And the next statement is what? A certain amount of water is now poured in the organ pipe so that the fundamental frequency is increased to 110 Hertz. So new fundamental frequency is what? 110 Hertz. So V is 30 over 4 L2 equals to 110. So L2 will be equals to 3 by 4 okay meter. Now the change in length delta L will be equals to 3 by 4 minus 11 by 4. So it will be equals to delta L will be equals to what? Or we can write 11 by 4 minus 3 by 4. So it will be 4. 11 minus 3, 8 by 4. So delta L will be 2 meter. Okay. So change in volume will be equals to area into change in length. Area into change in length. And area is what? Area is given as 2 centimeter square. So 2 centimeter square into 2 meter means 200 centimeter. So it will be 400 centimeter cube change in volume. So the amount of water poured in the organ pipe will be M will be equals to 400 gram. 400 gram means since density equals to 1 gram per centimeter cube. So 1 gram per centimeter cube means the mass amount of water poured will be 400 gram. Okay. Now next question 60. A ceiling fan having 3 blades of length 80 centimeter is rotating with an angular velocity of 1200 rotation per minute. The magnetic field of earth in that region is 0.5 Gauss. An angle of dip is 30 degree. We have to find the EMF induced. So this question is from the chapter of rotational motion. Now, according to this question, we are given with a with are given with 3 blades. Let us say these are 3 blades and they are having a length of 80 centimeter, okay, and they are rotating with the angular velocity of 1200 rotation per minute, means 1200 over 60. Okay, the magnetic field is 0.5 Gauss. 0.5 Gauss means 0.5 into 10 to the power minus 4 Tesla, and angle is 30 degree. We have to find the induced EMF. At first, the magnetic field V will be equals to B sine 30 degree. It will be B is what? 0.5 into 10 to the power minus 4 into sine 30 is 1 by 2. So it will be equals to 1 by 4 into 10 to the power minus 4. Okay. And then omega, angular frequency omega is 2 pi f. So it will be equals to 2 pi, and frequency is rotations. This rotation per minute, na. So 2 pi into what? Rotation per minute means 1200 over 60 radian per second in terms of radian per second. So this will be equals to 6 to the 12, 20 means 40 pi. Okay. And EMF, formula for induced EMF is what? Half BV into omega into L square. Okay. So it will be equals to half B is what? 1 by 4 into 10 to the power minus 4. Omega is 40 pi into L. L is given 80 centimeter, means 80 into 80 into 10 to the power minus 4. Now solving it, we get 4 cancels out each other. 2 4s are 8, 8 4s are 32 into pi into 10 to the power minus 5 volts. So our answer is induced EMF is 32 pi into 10 to the power minus 5 volts. So the value of N is 32.